Hello students, welcome back to the site of resonance. Today we will going to start reflection of sound. In the previous class, we have studied about the velocity of sound in different mediums like solid, liquid and gas, and we concluded that the speed of sound is maximum in solid than in liquid than in gases. Then we have seen that speed of sound depends on temperature. As you increase the temperature, the speed of sound gets increases, and when you decrease the temperature, the speed of sound decreases. We have also seen the effect of pressure on the speed of sound. If there is a constant temperature, if you have taken some certain temperature, then speed of sound is independent of the atmospheric pressure or the pressure. Okay. Then today we will going to start the reflection of sound. So beginning with the reflection of sound, let us see. Let us see what is reflection of sound. See, when sound waves strikes an object, it bounces back into the same medium. The phenomena of bouncing back of sound wave into the same medium after striking some surface, that phenomena is known as reflection of sound. उस phenomena को हम क्या बोलते हैं? Reflection of sound. जैसे कि sound wave आई वहाँ से इस बोर्ड से टकराई और बाउंस बैक हो गई उसी मीडियम में जिस मीडियम से साउंड वेव चलकर आई थी, इस फिनोमिना को बोलते हैं रिफ्लेक्शन ऑफ साउंड. For example, I am taking a surface. This is a surface that I have taken. Okay. This is the incident sound wave. The sound wave which comes and strikes the surface is known as incident sound wave. So this is incident sound wave. The point at which this incident sound wave strikes the surface, this point will be known as point of incidence. This point is known as point of incidence. After striking this surface, the sound wave will going to reflect back, means it will going to bounce back into the same medium like this, and this wave which is reflected after striking this surface is known as reflected wave. So what we have seen, the wave which is coming and striking the surface, that wave is known as incident sound wave. The point at which this wave strikes this surface is known as point of incidence, and the bouncing back of this wave into the same medium is known as reflected wave. This wave is reflected wave. At the point of incidence, if I draw an imaginary line, if I am drawing an imaginary line such that it is perpendicular to the surface like this, then this imaginary line is known as normal. This imaginary line is known as normal. So we are having three things. One is the incident sound wave, the other is the reflected sound wave, and the third is the normal. There is also a point of incidence. Now the angle which this incident sound wave makes with the normal, this angle, this is known as angle of incidence. This angle is known as angle of incidence. That is the angle that the incident sound wave makes with the normal. This angle is known as angle of incidence that I have shown with a small I. The angle which reflected sound wave makes with the normal, this angle that I am denoting with a small r is known as angle of reflection. It is known as angle of reflection. So what now we are having? We are having an incident sound wave, we are having a reflected wave. We are having a normal and we are also having a point of incidence. The angle which incident sound wave is making with the normal is known as angle of incidence, and the angle that reflected wave is making with the normal is known as angle of reflection. I am denoting angle of incidence with a small I, and I am denoting angle of reflection with a small r. Now, whenever there will be reflection, the phenomena of bouncing back of a wave, sound wave into the same medium after striking a surface is known as reflection. This phenomena, whenever this phenomena will going to take place, there will be two laws that this phenomena will going to follow. That laws are known as laws of reflection. So moving to laws of reflection. So whenever there will be reflection means whenever there will be this phenomena, these laws will always going to be get followed. तो ये दो लॉ हैं जो हमको पढ़ने हैं, हमेशा जब भी रिफ्लेक्शन होगा ये लॉज फॉलो होंगे ही होंगे. द फर्स्ट लॉ इज दैट एंगल ऑफ इंसिडेंस is equal to angle of reflection. Means angle I will always be equal to angle R. ये एंगल I हमेशा एंगल R के बराबर होगा. रिफ्लेक्शन इसी तरीके से होगा कि एंगल I हमेशा किसके बराबर आए, एंगल R के बराबर आए. दिस इज माय फर्स्ट लॉ ऑफ रिफ्लेक्शन. That angle I is always equal to angle R. Now moving to the second law. What is the second law of reflection? Let's see. The second law states that incident wave, reflected wave and the normal at the point of incidence all lie in a same plane. Means incident wave, reflected wave and the normal at point of incidence all lies in same plane. अब इसका मतलब क्या है आप समझिए. See, these are the three waves. This is the incident wave that I am showing with blue. This is my normal that I am showing with green marker, and this is the reflected wave. See, angle I will always be equal to angle R. This is the first law, it is fulfilling. If I am taking incident wave like this and I am taking reflected wave like this, see, again angle I is equal to angle R. Means angle I अभी भी angle R के बराबर है, first law follow हो रहा है. But I cannot make a common plane which will contain all these three waves. एक कोई भी common plane नहीं बन सकता जो इन तीनों waves को contain करे. तो ये सेकंड लॉ को फॉलो नहीं कर रहा. मतलब अगर इंसिडेंट वेव ऐसे आ रही है तो वो रिफ्लेक्ट होकर ऐसे नहीं जा सकती. उसको रिफ्लेक्ट होकर कैसे जाना पड़ेगा, उसको रिफ्लेक्ट होकर कुछ इस तरीके से जाना पड़ेगा कि ये तीनों एक प्लेन के अंदर लाई करें. सी नाउ, ऑल दीज थ्री वेव्स आर लाइंग इन अ सेम प्लेन, दैट इज द प्लेन ऑफ माई हैंड. इंसिडेंट वेव, नॉर्मल एंड रिफ्लेक्टेड वेव तीनों एक ही प्लेन में लाई कर रहे हैं, जो कि प्लेन क्या है, इट इज द प्लेन ऑफ माई हैंड. इट इज द प्लेन ऑफ माई and you can see over here angle I is equal to angle R and all these three waves are in a single plane, that is the plane of my hand. तो ये तीनों एक ही प्लेन में लाया कर रहे हैं, मतलब सेकंड लॉ भी फॉलो कर रहे हैं, फर्स्ट लॉ भी. मतलब ये रिफ्लेक्शन पॉसिबल है. लेकिन अगर मैं बात करूं कुछ इस तरीके के रिफ्लेक्शन का, तो ये रिफ्लेक्शन पॉसिबल नहीं है. क्यों? एक कॉमन प्लेन नहीं बना सकते आप. देयर कैन नॉट बी अ सिंगल प्लेन विच विल गोइंग टू कंटेन ऑल दीज थ्री, these two waves and the normal. Okay, so that is the two laws of reflection. Whenever there will be a phenomena of reflection, these two laws will going to be followed. Okay, angle I is always equal to angle R. Incident wave, reflected wave and the normal at the point of incidence must lie in a single plane. These were the laws of reflection. Now there is a very simple activity to prove these laws of reflection. Let's see that activity also. See, the activity is like this. I am taking a wall, this is a wall. Now I will going to have two cylindrical pipes, hollow pipes, two cylindrical hollow pipes. So I am having one pipe like this. It can be a pipe of cardboard. So I am taking a pipe, cylindrical hollow cardboard tube like this. Okay, I am having another tube. Like this. Okay, so I am having two cylindrical tubes, hollow tubes of cardboard like this. I have placed a clock over here. I have placed a clock over here. So this is a ringing clock that I have placed over here. Means alarm clock, or you can say a clock will going to produce sound. There is a source of sound over here. Now I will going to move this cardboard. This is the cardboard A and this is the cardboard B. I am having my ear over here. I have placed my ear at this cardboard end. So the sound will going to come from this clock. It will going to travel through this cardboard and will going to strike this wall. Now I will going to make this cardboard, that is the cardboard B, move, cardboard B tube move here and there. And I will going to listen the tickling of clock. I will going to listen the tickling of clock. Wherever there will be a sharp tickling of clock, I will going to stop. Then I will going to measure this angle with normal and this angle with normal. And what I will going to find? I will going to find that angle I will be equal to angle R. Whenever I will going to listen a sharp tickling of clock. There you will going to stop, then you will going to measure these angles and you will find that angle I is equal to angle R, means the first law has been proved with this simple activity. Now to prove the second law, you will going to move this cardboard up and down. If this is the cardboard tube, you will going to move it like this, up and insideward down. You will going to find that this tickling of clock will be sharp again when it will be in the same plane, that of normal and this cardboard. So second law of reflection will also be going to get proved. So this is how you can prove with a simple activity the laws of reflection. The laws of reflection. This is how we can prove the laws of reflection with the help of a very single activity. Now let's move to some practical applications of reflection of sound. So moving to some practical applications of reflection of sound, I am taking the first application as the soundboard. So this is a soundboard which is present inside a hall. And at its focal point, the speaker is present. Or you can say the source of sound. What will going to happen when the person will going to speak? There will be sound wave produced in all directions, isn't it? And the sound waves which are produced in the backward direction, it will going to move like this. After reflection, as it is on the focal point of this board, soundboard, they will going to become parallel. They will going to become parallel like this. And here what I am having is the audience. So they will going to get a clear voice of the speaker when he will going to speak due to the reflection of soundboard which is at the back of the speaker, which is in a concave type shape, and the speaker is standing at the focal point of this concave structure. That is known as soundboard, which helps in a clear voice of the speaker to the audience. Soundboard. Second is megaphone. Generally used by police, and a megaphone looks like this. Okay. So here there is a source of sound. When the source of sound will going to speak, there will be a reflection going like this, and this will going to become parallel after some reflection. The other wave will going to move like this, and after reflection it will going to become parallel again. So after multiple reflections, the sound will going to become parallel in a megaphone. So there will be a loud voice generated by a megaphone. When I am speaking normally, what will going to happen? My sound waves are going in all direction. But when I will going to put hand in front of my mouth, what will going to happen? My sound wave is concentrated in a single direction, that is in the front direction. That same thing is done by a megaphone also. So all the sound waves are concentrated in a forward direction, making the sound much more louder and clear. So it is used by policemen. You have seen in many movies also, they use a megaphone whenever they want to deliver some message to the thief or to a crowd. So this is a megaphone. The third application you can see is as a stethoscope, that is used by doctors. So there is a tube, and then these are the earpieces. Okay. So what happens? The heartbeats, the vibration of heartbeats, disturbance will going to travel from here, and there will be a number of reflection taking place in this stethoscope tube like this. And the sound will be reaching into the ears. The sound will be reaching into the ears of the doctor. So there will be a clear voice or the clear sound of the heartbeats of the patients. So this is how reflection is having another application in the medical field also, that is in stethoscope. This was a megaphone, this was a soundboard. So we have studied today about the laws of reflection, what is the reflection phenomena in sound, then we have seen the practical applications of reflection of sound. Now there is a great application that is known as echo of sound that we will going to start in our next lecture. We will going to calculate the minimum distance required for an echo, and we will going to see how echo is used in various places. So thank you for today. We will going to continue in our next lecture.